Hello and welcome to this quick demonstration of my final year project. So you can see it here, it's open here in PyCharm, it's entirely in Python. It is about just under 900 lines long and it's pretty simple Python, nothing state of the art. So we will run it here and it runs in a program all in Kinter. So this program, and I'll give you a bit of background on why I made this. So, well, I made it because I want to pass college, but my supervisor, I came to my supervisor, I wanted to work with him, and he had this problem. So he would run these incremental exercise tests. So I'll get you up a YouTube video here. This is what an incremental exercise test looks like. So you see the athlete here, he has the thing over his mouth, which is measuring his VO2, which is the volume of oxygen in his blood, then compare it by the air that comes in, the air that goes out. And then he has a heart rate strap on. And that's measuring, as you guessed it, heart rate. So those two variables are measured digitally, well, physically, and they're outputted digitally in a CSV file. Other data, which is measured, such as the speed of the treadmill, if they're doing it on a treadmill, or the resistance of the bike that they're racing on, which would be like, for example, 120 watts. That's just on the screen of the bike or the treadmill. And then blood lactate, you'll see this technician here. She's taking blood lactate samples by pricking their finger and drawing a blood sample and putting that into a machine, which spits out a number. All that's measured manually. And the way the test works is every 3 minutes or 5 minutes or whatever, but it's measured in increments. So you'd have the athlete going at, let's say, 120 watts for 3 minutes. And at the end of the 3 minutes, take a blood test, increase the speed to 150 watts. Wait 3 minutes, take another blood test, increase the speed again. And you do that for about 8 stages, so somewhere between 20 and 30 minutes. And at the end, you'd be left with a data set that you'd written by hand. And you have your data set, which is on the computer. And it takes the lab technician about 15 to 20 minutes to merge those data sets together and to draw useful insights and literally plotting graphs by hand by drawing the X and Y axis and plotting the points. So as you can imagine, that's a pain in the ass and it's wasting the supervisor's time, and like he's a doctor or a PhD and you're wasting a sports scholarship student in Trinity's time and just wasting everyone's time. So he wanted a piece of software that would speed up that process, and hence this software is made. So the test is almost the exact same for runners or cyclists, or rowing or kayakers. Rowing, kayaking, or cycling, it's measured in the bike's power, resistance, which is in power, measured in watts. Or if it's a runner, it's the speed of the treadmill, which is in velocity, measured in kilometers an hour. So generally starting off, blood lactate would be about 1 at a warm-up speed of about 9 kilometers an hour. That stage will end after 3 minutes. The next stage, the blood lactate probably 1.1 at 10 kilometers an hour. That stage will end at 6 minutes. And now, for example, if you enter the wrong number, so if you say 220, whatever that is, at a speed of 900 kilometers an hour, ending at 999,900, that won't be allowed. Invalid blood lactate entry. It has some text validation, but even if you have that, yeah, so it has a bit of text validation just to make sure you don't enter silly things. And yeah, so you do that for all 8 stages, and at the end you can export that as a CSV, which would look something like this for if you're a very fit runner. So definitely not me or you, probably not you. So yeah, and then you can use that data set right away. Assuming you had a full one here, you just click the Use Data Now button, but we won't do that because we don't have one now. So we'll just import it here. So we can import the Gui Data Set, which is that one I just showed you, which is here, a2.csv. And then the Cosmet Data Set, I'll give you a look at that. Cosmet is the company that makes the chest strap and the face mask that measures heart rate and VO2. So this is the data set. I will move this so you can see. But yeah, it's, as you can see, it's just a gorgeous data set. Not. It's quite big. I'm only using 2 variables in it, but it's still quite long. It's about 1,000 entries. Yeah, just over 1,000, but 27 minutes of data. So yeah, if we just import that here, this is it here, and then we just click generate report, and it will, where do we want to save it? We'll save it here, call the folder test for video. Path does not exist. Oh yeah, make the folder first. Test for video, select folder, and now it's loading the report. It has to generate a PDF, so it takes a few seconds. And yeah, we're ready, so let's view the report. And boom, it spits us out this. Now, as you can imagine, this would take a while to draw, to make by hand. This data here, the heart rate and the VO2 data is actually the average from the last minute of every stage. But so that's how that's calculated. And this table is very important. All of the tables down here are all made using just this data set. And then a couple of statistical calculations are made. So VO2 max is pretty easy. It's the highest 5 rolling average, 5 count rolling average. And that's 64, so that's incredible. This is a very fit athlete who might be famous now. Some of you might actually know him. This was only when he was 16. A lot of Premier League athletes, like Richard Dunn, I doubt his VO2 max ever went above 64. Not for long anyway. So to have that at 16 is incredible. This guy's running sub 3 marathons, I could almost guarantee you. And then Dmax velocity. So Dmax is a method for measuring. So if you were to have a line here, see on this green line, which is blood lactate, if you were to have a line starting here, straight line, ending at the last point, and then you were to bisect that with a perpendicular line, where would that intersect the blood lactate line? And it would be at about a velocity of 13.8 and a blood lactate of about 1.8, which you can see here. And that is a method for estimating functional threshold pace, which is a pace that you can hold indefinitely. So assuming this runner was conditioned through strength and connective tissue to run for 12-15 hours, their aerobic system would be able to keep up. They could run that long. It wouldn't be their aerobic system giving up. That's their functional threshold pace. And there's lots of methods of estimating that. But it's a lot easier to estimate when you have the data right here. So if my supervisor, Neil, ever wants to create a new method for estimating functional threshold pace, he can just write the code in Python and he'll have all these data sets from hundreds of athletes ready to run his estimates on. So that's one of the values of the code, is that it offers him hundreds, maybe even thousands of data sets that he can use for his research, and he can use it. It's a standardized data set, so he can use to compare the control group against the study group or the sample group, or to compare the progress of the focus of the study, the control group, from the start and the end of the study. So it's very useful. And these plots here, the dots are the points from this data set, and then the line is an interpolated line. So that's just estimated. So that's why it's curved and it's not straight from point to point. And that's why I use the interpolation function, which you might have seen here. Did I show the packages I used? Yeah, so I used this interpolate function here. So yeah, this is the report. Yes, that's my final year project. If this interests you, if you work in the field of athlete testing or anywhere where sports analytics merges with kind of errs on the side of data analytics and software development, reach out to me because because I'd love to work with you on that. I find it interesting and I enjoy it. So yeah, I hope you enjoyed. And the source code is all in a Google Drive link below and in a GitHub link below. And if you want to download an exe file which runs that Python file, so I know some of you might be watching this and you're just interested in using the application for your own uses, and you don't want to install Python so you can run this program, that's fine. Install the exe file. It will tell you it's a virus. I give you my word, it's not a virus. But so yeah, thanks for watching.